Hi, welcome to this lesson on number patterns, sigma notations. Let's have a look at solving a sigma notation problem, question 5. Let's determine the value of this following series. The sum from n equals 1 all the way to infinity now of 3 times a half to the power n. So now the upper bound is saying infinity. And we generally know that when we add infinite number of terms, they generally tend to diverge to positive or negative infinity. However, we did learn of a nice type of sequence where the series will converge if you add them up infinitely many times, and that was known as the infinite geometric series. And if we look at the sequence structure of this expression, that definitely looks geometric to me. So I'm going to call t sub n 3 to the 1/2 to the power n. So 3 times 1/2 to the power n. So let's have a look at the first few terms. So I'm going to write tn out. When n equals 1, it's going to be a half to the power 1, which is a half, times 3, which is 3 over 2. T2 is going to be when n equals 2, so it's going to be 3 times a half squared, which is going to be 3 over 4. Next term, when n equals 3, it's going to be 3 times a half cubed, which is 3 over 8, and so on. So, our first term a is 3 over 2, and our common ratio seems to be that we are multiplying by a half to get to the next term each time. So, r being a half satisfies that golden special property of being between -1 and 1, not including those n values. So therefore we know that S infinity converges, the sum to infinity converges, which means it exists, and it's given by a over 1 minus r. So that's again another very important formula on your formula sheet, and it's only applicable to an infinite geometric series that converges. And that property of convergence is given by that constant ratio falling between that given interval. So this thing here is the same thing as saying the sum to infinity of this general sequence term here, which is given by a over 1 minus r. Our a in this case was 3 over 2, all over 1 minus r, which was a half. So let's do some arithmetic there. In the numerator, I have 3 over 2. In my denominator, I have 1 minus a half, which is a half. When you divide by a fraction, you multiply by its reciprocal. So the reciprocal of 1 over 2 is 2 over 1. And therefore, those 2's will cancel into each other, and you're left with 3 divided by 1, which is 3. So this infinite series converges and is equal to 3. Now, unfortunately, on your calculator, you can't really sum to infinity here, but we can get a good idea as n gets larger and larger. So if I said the sum from, for example, 1 to 10, that's pretty small. But let's see how close the number gets to 3 as we increase that. So that's raised to the power x, and that was a half. So it's important how you type it into the calculator correctly. So I press equals 2.997, that is pretty close to 3. And we know that if we kept adding more and more terms, it will converge to positive 3. So let's say if I did 20 terms now, can the calculator handle that? Yes, 2.9999971, that's even better approximation. I don't know if the calculator will let me go to maybe as far as 100, let's see. Oh, look at that. So what the calculator is doing here is it's approximating. You're adding up 100 terms and it's saying, well, no, that's good enough. It looks like it's going to 3, so I'll converge it to 3. But that's exactly what the sum to infinity is saying here. It's if you could add up those terms infinitely many times, all the way up to infinity, which we know humanly, physically is impossible. That's why we say it converges. It gets closer and closer to that value 3 as you keep on adding more and more terms of that general term there. Okay, and that is the solution to this problem. I'll see you in the next one.